All right, today we are going to talk about permutations. And what a permutation is it's a rearrangement of something. We're trying to say, well, if I have some stuff here and I switch their orders around, that's called a different permutation. Yeah. To permute something would mean to move it around. A permutation is what that specific order might be. So, for example, here, I just kind of grabbed a few things and said, well, here is one permutation, right? We have basketball, football, softball, right? But I could rearrange this, right? And I could exchange these three around, and it's still the same stuff, but this is a new permutation, right? They are in a different order. And same thing, we could kind of switch some stuff around here, and this is, again, a new permutation, right? That's what a permutation is it's the different arrangements of, how these things would be. And those are different permutations. And the thing we want to do a lot of times in math is count up, how many ways is that possible, right? That would take might take a little while. It's not too bad with three objects, but as you get more and more, that can take a little while to try and see, well, how many different orders can you do this in, right? Because all you have to do is switch two things around and you have a new permutation. You can obviously switch more, but all you need to do is switch two of them. So in here, just to kind of visualize, what I'm talking about a little bit, I'm going to take this same example. And kind of the thing that we can do is when we start here, we can sort of say, well, we just need to pick for the first spot. We need to pick either one of the three things, either softball, basketball, or football, right? We need to put that first. And then the second object, well, after that, you have two choices from there, right? I mean, if I've chosen the softball, I have one of these two left, basketball, and so on. And then after that, your third choice is sort of chosen for you, right? It automatically has to be whatever that last thing is. So here we could look at, all the different permutations. Here we can see there are 1, 2, 3, 4, 5, 6 different ways, 6 kind of unique ways that can be arranged, right? And we could kind of say, wow, do we have to go through and, order everything? Well, not really. I mean, here we had 3 options and then 2 and then 1. I mean, just like with probabilities, if we multiply those successive choices, we would get the total, right? So here, that's kind of what I did. So, well, if we take our 3 choices times 2 choices times 1 choice, that will tell you the total number of choices that would be possible, or the total number of permutations. And what's nice is this speeds up some of this stuff. Like, we don't have to make these big giant tree diagrams. We can just kind of speed that up, because then if we went in and said, well, if we got 4 of them, boy, that would take a while to sit there and rearrange all of them. However, it'd be pretty quick if we just did the math, right? I just said, well, I have 4 options for the first choice, for the first spot. And then once that's picked, you have 3, then 2, then 1. And we just multiply this together and say, oh, 4 times 3 times 2 times 1, that's just 24. There are 24 different ways you could, rearrange these things, right? And I don't want to sit here and, try and, switch that around. Did I actually do that one? Did I not? Not, doesn't matter, right? We can figure out how many ways there are to do that, right? So that there is how you can do a permutation. You just start with what you have and move all the way down. And what this is called, this kind of has a nice pattern, right? We start at whatever the number of things are, and then we have one less, and then one less, and then one less, and we're multiplying all of that. And that gets used fairly often in math. So there's actually a special name for what that is called, and that is called a factorial. And that's represented by an exclamation point. So it doesn't mean that you're super excited if you use an exclamation point in math, although I know most of you guys are, because what else would you be excited about? So in here, when we have a exclamation point, again, even though I know you are excited, it doesn't mean that. What it means is we're going to start at whatever that number is and multiply all the way down to 1. So if I put 8 factorial, that's how I would read that. It would be 8 times 7 and then all the way down to 1. And then I'd need to grab a calculator and just type that all the way down, 8 times 7 is 7. And now the nice thing about a lot of calculators is there is a factorial button on most calculators if they're a scientific function. You might have to look for it a little bit. I know on the one that I have to hit the button that says math and then go across the top to where it says PRB for probability. You guys might have a calculator that has a button that says PRB right on there, and that stands for probability, and you can find there's one that has an exclamation point on that. And if you don't have any of that at all, Desmos has a scientific calculator, which this will be looking a little bit at tomorrow. I was kind of testing that. But it does have a factorial button in there. If you want to go into like functions, there is an exclamation point right there. Or if you're on a keyboard, you can always just type that in. So like if I wanted to do, you could sit here and do 8 times 7, and you could type every single one of these little things. Oops, man. And then you make a mistake and you got to fix it and do that. And I'm not going to type the times 1, but we can do that. But you can also just do 8 factorial, and it's built in, right? So in a lot of calculators, that stuff's built in. If you don't want to type each individual number in, you don't have to, jump online. You can also just put it right into Google, right into the search bar here. I can just type in 8 factorial, and it will know, oh, hey, you're doing that. So you can type that right into a search bar as well, and it will do that as well just onto Google. So if you're looking at, did I do that right? And you don't want to type out every single number, don't. Just use the factorial. It makes it a lot faster. Okay. So an example of where we would do that, if I want, maybe we got a bunch of cars and want to say, well, how many ways can I rearrange these cars? Well, first I would count how many there are. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of them, and maybe I want to put them in order and show off all the fancy cars that Mr. Haugen has with all his lots and lots of money that he has sometimes when he's dreaming. But so in here, what we would say is, well, that's just 10 factorial, right? And I don't want to take the time to type all that out. So again, I'm just going to go over to a calculator and type in 10 factorial and just hit enter and see, oh, that's actually 3,628,800 different ways to do that, right? And I don't want to spend the time typing all that in, so I'm just going to, copy that right into there. Maybe I'll put my commas in there as well, so it's a little bit easier to see. But that's how many different arrangements there would be, different ways you could line up 10 things. Factorials get very large very, very quickly in there, right? But that's how you do factorials, arrangements of things, permutations. But there's one last thing we need to go over, and that is, what if we're not going to use all of them, right? You don't necessarily have everything and then you grab all of it. Sometimes you have, like in this case, 9 different things, and we're only going to arrange 5 of them. What would we do? Well, how this would work was we would say, well, if we were going to use all 9, we would say that's 9 factorial. And if we're just going to use 5, basically what we do is we say, well, we're going to take and keep the first 5, right? Because we'd have 9 choices, then 8, then 7. We would actually just keep the first 5 of them, 1, 2, 3, 4, 5 values in here, and we would not use these ones. Now, the little more difficulty with this is it does not fit as nicely into a calculator. You do have to type all of these into a calculator there, and we just ignore using these ones. So to arrange those, what we would say, well, we would just take 9 times 8 times 10 times 65, right? This is all we would do. And in that case, I wouldn't be able to, have a quick way to do that. I would have to type each individual one in. There's still 15,120 ways to do that. So I would still know that that's equal to 15,120. Oh, 100. Still type it wrong. 120. There are that many ways to arrange, those things, maybe in a closet or something, where maybe we're putting all those. But in there, where you have a certain stopping point and you're only keeping part, you only keep the stuff that you want. You don't keep the extra ones. Okay, so that's just a little bit of a piece on there where you're not going to include everything. You have a partial permutation where you only keep some of it. We just keep that number of items, and then we ignore the rest of the factorial, right? We just sort of cancel that off or remove it. Yeah, so that is it's on permutations. There are a few questions down there for you. If you guys want to type some stuff in, or if you guys have questions for me, just make sure to go ahead and let me know on that. And if nothing else, I'll see you guys tomorrow.